Question 8 is coming from transformation of functions. The diagram shows part of the graph of y is equal to sine of a then into x plus b, where a and b are positive constants. Part A, state the value of a and one possible value of b. Okay, now I'm going to look at these values here. This curve passes through this point here, 0 and then 0.5, 0 and then 0.5. Now, at this point here, this expression here, this function is equal to that 0.5 when x is what? 0. So that means we shall have 0.5 then will be equal to, that is the y coordinate, right? So I'm substituting here. Then x is a 0. So meaning we shall have a times b here. So we shall have sine of ab. You see that? Okay. Then from there, ab will be equal to the arcsine of 0.5. This one gives us 30 degrees, okay? So meaning I can have AB, which is equal to, let's say, pi over 6. Then I can express one in terms of the other, okay? Or I can leave it there as my first equation. Then we can also look at another coordinate. There is this one here. This curve cuts x-axis at this point here. So we have 5 over 3 pi and then the 0. Not so? So y is 0. So I'm substituting here again. We have sine of now ax. Okay? If I open the brackets, x is 5 pi over 3 of a, then plus ab. Not so? When you multiply here, then this one shall be equal to the 0. You see that? So meaning, when you get the arcsine, this is 5 pi over 3 of a plus the ab will be equal to the arcsine of 0, which is actually 0. Okay? By the way, arcsine of 0 can give us, we have 0, we have pi, we have 2 pi, like that. So if I take right from here, by the way, I can get the value of a from here. So this one can be 5 pi over 3 of a, okay? This one here is pi over 6. From here, what we have gotten, okay? Then is equal to, if I put 0 here, okay? I will take this one here and it becomes a negative. Then when I divide through by this, I will still get a negative. Do you see that? And yet they said that a and b are positive what? Constants. So meaning I'm not going to take 0, but instead I'll maybe take this one, the 180. So I will have here pi. And then my a is going to be equal to pi minus that pi over 6. Then I will divide by 5 pi over 3. So what will be our a here? Now, of course, pi is going to disappear. So 1 minus 1 over 6, that one will give us 5 over 6, right? Then we divide by 5 over 3, okay? Down here. So meaning you have 5 over 6, then times the reciprocal of the denominator, 3 over 5. So this one disappears, and then you have a 1 here, and then a 2 here. So meaning our a is going to be equal to positive a half. As simple as that. And then for us to get b, then I can go back to the first equation we got, okay, here. So our b is going to be equal to pi over 6. Then I divide by the value of what? Of a. Now this one will be pi over 6, then times the reciprocal of this one is 2 over 1. So meaning this one will reduce this by 3, okay? That means we are going to have pi over 3. So the value of b is going to be pi over 3. As simple as that. Then they are saying that another curve with this equation y is equal to f of x has a stationary point at the point pq, where p and q are constants. this curve is transformed to a curve with this equation here. Then part B, for the transformed curve, find the coordinates of the stationary point, giving your answer in terms of P and Q. Okay, now, this is how we are going to start. You see that this 8 here is inside here, but then there is a quarter here. That means the first thing that is done here, you have to first stretch this one. Then when you are putting this one here, it will come to this X and then in that bracket like that. You see that? So this is the order of transformations. This is the order. I want to be systematic. The order of transformations. Okay, so we have y1, which is equal to then f of, remember you have this one, so there is this a quarter. So we are going to have a quarter of x. Okay, and here we say this is a stretch by factor. A stretch by factor 4 parallel to x axis. Here it is a quarter, but then the factor here is 1 over that a quarter. Okay, so that is that. Actually, in my chapter summaries here, if we can look at functions are here. So for stretch in the x, that is to do with the multiplication on the x. You see this ax here? Okay, look at that ax here. Then they are saying is a stretch factor 1 over a, then parallel to x-axis. Now, when I try to take you to this graph, let's say here, and we are having, let me use the sine curve, y is equal to sine of x, okay? And then we also draw another one for y, which is equal to sine, let's say 2x, okay? Something has been done on that x there. So you can see that the x coordinates here, the period of this one has reduced. Okay, the period of the first one has moved. Okay, now you check this one here. 0, then it repeats itself, the red one, it repeats itself after 2 pi. You see the 2 pi? Okay, but then this other one, the blue one, it repeats itself after pi. Are you seeing the pi? It is here. Okay, so because of that, the x coordinates have now divided by 2. Or, if I actually, let us now put another one, y is equal to, then sine of, let's say, a half of x. A half of x. Now you see, for each it widens. Okay, sorry, this one widens. So suppose I put off the other one. Now the period of this one, the green one, is actually now 4 pi. If we go and we look at this 4 pi, for the other one, it is what? 2 pi. Okay, this one, it widens. So you have 1 over half, it is going to give you 2 times. That is why the period here is 2 times. If I use the quadratic, and we have y is equal to, let's say, x squared. Okay, y is equal to x squared. This is the one we are having. But then I have y, which is equal to, let's say, 2, then x, then squared. Okay, you see that here, the x coordinates, for the same y coordinate, the x coordinate has divided by 2. Look at this x coordinate here, 1. Now let's look at the y coordinate. The y coordinate is 1, but the x coordinate here is 0.5 for the new one. Or you look at, for the same x coordinate here, I mean for the same y coordinate, 2 here. Okay? 2 here, then this one is 4. But then for the same y coordinate, the x coordinate here is 1. It has divided by 2, it diminishes. But then suppose instead of having a 2 there, then I'm going to have, let's say we put a half y, which is equal to, then I put in brackets, 1 over 2, then after that, we put the square. X, then squared, right? I want you to see this one now widens. So for the same y coordinate, this y coordinate here, 1. Here x is 1 for the original, but now for this next one here, x here has doubled. Do you see this one? So here we have put a half, but now here the x coordinate has doubled. So 1 over 2, that's why they say 1 over 1 over 2. It is 1 over a. The a you are having here is the coefficient of x. You see that? So that is how the x is now going to change here in the diagram. You see that? So that's why in the question here, where there is a quarter, then we are saying that the stretch factor is what? A 4. Because we have put 1 over 4, which we are having here. I hope I've made necessary noise. Okay. Now from there, that means the x coordinate here, which is p, now it is going to be multiplied by the 4. Are we there? So the p is going to go to 4p. Now, the second one that is going to come from here, we are going to have f into, now 1 over 4, already x is divided by 4. Now we shall bring in the 8. The 8 has to come inside here where x is already divided by 4. You see that? It is like that. This one is a transformation. Actually, we call it a translation. Okay, a translation by vector negative 8, 0. Because when this one pops out of here, it does what? It changes the sign. I've always shown this one. Even when we come back to this one here, and I take away this one, then we have y, which is equal to, let's say we have x here, and we say let's say plus 2. Okay, you can see that it has moved to the left by 2 units, meaning this is a translation by vector negative 2, 0. So that means when this one is popping out from the function here, it comes here in the translation vector as a negative. You see that? If we put a minus here, it now goes to the right. You see that? That means the translation vector is 2, 0. You see? So that's why here in the chapter summaries, we have that if you have this one here, the graph of y is equal to f of x plus a. This is a translation of y is equal to f of x by the vector negative a, then the 0 here. You see that? So if you have a minus, a plus here, then it changes the sign here. If you have a minus here, then it will come here as a positive. Does that make sense? Okay, now we come to this one here. That means we are going to get the x coordinate and we subtract what? 8. So the 4p is now going to become 4p minus 8. Are we there? Next, now we shall multiply by this negative 3. So y3 is going to be equal to negative 3, then f over quarter, then x plus 8, like that. This one is going to be the stretch. A multiplication is a stretch. So stretch by factor negative 3 parallel to y-axis. We are putting parallel to y-axis because you can see right from here, if the multiplication is in the function, then it is parallel to y-axis. If the multiplication is on the x, then it is parallel to x-axis. You get that? Okay. Now, falling back to what we are having here. By the way, I've put this one as a negative, but we can also write this one as 2 transformations. We can say stretch by factor, positive 3 parallel to y-axis, and then because there is a change of sign here, then we say reflection in the x-axis, because when you reflect in x-axis, the x coordinate here remains, but then the y coordinate changes the sign. So for the change of sign, we look at reflection. You see that? But if you take the negative right away here and you give it to this 3, so you don't have to talk about the reflection. Okay? So the graph will just reflect itself. Now, here we are going to get the y coordinate. We multiply it by -3. So what is the y coordinate? Is q. So we shall get q here. Then we multiply it by -3 and it becomes -3q. So meaning our answer here is going to be the coordinates of the stationary point for the transformed curve. They are going to be 4p minus 8, then -3q. Okay, that is that.